So for this bell work, we see some parentheses, so we are expecting some distribution here as usual. When we see parentheses, so I'm going to distribute this 4 into the parentheses just to start out. So that's 4 groups of negative 2x's, which results in negative 8x's. Then also 4 groups of negative 5 would result in negative 20. So that's all the distribution I see. On the left side though, we're going to drop the negative 8x plus 6. Then this will equal the negative 8x plus 20. At this point, I think some of you guys would be done and could be done, but I'm going to continue just in case you didn't notice anything. So for me, I'm going to put the x's on the left, numbers on the right side of the line, meaning the plus 6. I'm going to have to zero out, so subtract 6 from both sides to zero that out. Now I can drop my negative 8x's, which equals, I'll drop the negative 8x's in red as well. And negative 20 minus 6 is going to be negative 26. And then next up, and this should finish the problem off for us, but since I got the negative 8x in red on the number side of things, I have to zero that out by adding 8x to both sides. On the left side, I got negative 8x plus 8x, which is 0 x's. And I need this x term here because it's on the x side of the line. Of course, we zeroed out the negative 8x's in red, but then the negative 26 can drop. Now, at this point, we need to notice, if you didn't notice it back here, or even at this point, you need to notice at this point that it's impossible to multiply anything by 0 to get negative 26. So this one simply has no solutions. Here's our 4 objectives. I can plot points on a graph. I can determine coordinates of points on a graph. I can graph and write equations from graphs in slope-intercept form, which we'll talk about. And also I can graph and write equations of vertical and horizontal lines. So 4 objectives today, but we actually have seen these before in 8th grade. It's just that we don't usually remember anything from 8th grade. So that's why we're reviewing this stuff. It'll help us to get started. This is 2.1, the start of Unit 2. So take a minute, copy these down, and we'll get started. All right, so most of this stuff is review. So if you know this stuff already, you're in good shape. If you don't know it by now, we need to get it down before the end of the lesson. And if you don't, then you got a lot of questions you probably need to ask. Because if you can't do this stuff, the rest of this unit is going to suck. What is a solution? A solution to an equation is a value for a variable that makes the equation true. It's just now we're going to start seeing equations with just two variables. It says or more variables, which you could have, but we just need 2. Okay, you usually have combinations of values that can make the equation true, okay? So for example, if you looked at this equation, y equals 2x, maybe you've seen this before, but we can find x and y values that would make this a true statement, okay? But it's a combination of x and y values. In the past, you've probably seen these shown as an ordered pair like this one, which we'll talk about. It's always the x value first and then the y value second because that's alphabetical. But in that equation, if I wanted to, I could replace the x, let's say with 4 as an example. If I replace that x with 4, I get a corresponding y value that is 8. How did I get 8? Because I did 2 times 4, which is 8. This also is why the y is what we call a dependent variable, because it depends on what is happening with x. Okay, once you get an x value, then you can operate with it, and then, only then will you get your y value, okay? Now this is one ordered pair, one x and corresponding y value that together would make this equation true, but we could, if we wanted to, find others. For example, if I wanted to, I could say, well, let's let x be 10. All right, fair enough, but if you let x be 10, what is the corresponding y value? Well, 2 times 10, that'd be 20. Okay, so 10, 20 also makes the equation true. And just to emphasize this, I'm even going to make the x value a negative. Let's say that it was negative 7, okay? If you said x was negative 7, then negative 7 times 2, that would give us the corresponding y value that is negative 14. So here's 3 ordered pairs that make this equation true. There's actually an infinite number of values that would make that equation true. It's just we want to show this in an easy way, and that's where the graphing comes into play, okay? But it's important to remember these ordered pairs and how they relate to the equations. So yeah, but all these would be, this ordered pair is a solution, this ordered pair is a solution, this ordered pair is a solution to this specific equation, okay? So horizontal and vertical number lines. Our horizontal number line here, which we've seen perhaps often in the past, maybe more in 7th grade. But usually right in the middle, we would put the number 0, okay? So in the middle, I got 0 on this horizontal number line, which hopefully we're used to. To the right is our positives. To the left is our negatives. And to the right, if I go from 0, usually every mark would represent 1. So this would be 1, 2, 3, 4, 5. And because I don't want to write the numbers 1, 2, 3, and 4 and just 5, that's what I have. Okay, but it's positive 5 because it's to the right of 0. Anything to the left of 0 would be negative. So that'd be -1, -2, -3, -4, and this would be -5. Okay, so we've seen this number line before. Now that we're graphing, of course, we're going to have a name for that. But then one that we're probably not as used to is the vertical number line over here on the right. Right in the middle here, you would have 0 again. If you go upwards, this is the positive direction, and then downwards is the negative direction. And these positives and negatives, the direction is important, which we will see later on. But again, I'm going to say that the scale of this, every mark is 1. So there's 1, 2, 3, 4, and 5. But it's above 0, so that's +5. And then below 0 would be -1, -2, -3, -4, and -5. Okay? So I get this vertical number line, and it's possible you could have done stuff like with addition and subtraction of integers with this type of number line. But what we're going to do is I'm going to take this number line here, and I'm going to combine it with my horizontal number line. Now when I do this, I'm going to need this vertical number line to go right where 0 is on this number line. And where 0 is on this vertical number line, I'm going to need to make sure that that's where the horizontal number line is, okay? And there's a reason for that, and of course I can't see that anymore because I'm covering it, but 0 here for my vertical number line, that's where this horizontal number line is, and 0 on the horizontal number line, that's where the vertical number line is. That means something, okay? But when we take two vertical and a horizontal number line like we just did, it creates a grid like this, okay? Now on this grid, we need to be familiar with some of the vocabulary that goes along with this grid, okay? For example, if we say something like x-axis, you need to understand that is talking about the horizontal number line. Okay, usually what they'll do on the grid is that here on the right, just above that thicker number line, they'll put an X there. That is to tell you that that is the x-axis. The y-axis then, of course, would be the vertical number line. Okay, and again, usually up here at the top, usually they'll put a Y right there. Now, if they don't, it's important for us to remember which one is the x-axis and which one is the y-axis. It is okay also to refer to these, like the x-axis, as an X number line, and the y-axis as the Y number line. Then we have the origin. The origin is right where the two number lines come together, and that, of course, is where here, this is where the Y would be 0, and this is where the X would be 0. Sometimes you'll see this with a mark like this, and then they'll put a, that's not the number 0, that's an O, O for origin, okay? But it does take on the ordered pair 0, 0. But that's the origin right there, okay? Origin, because in math, we usually start, that's what origin means, with 0, okay? All right, so an ordered pair. Let's look at an example of an ordered pair. Remember, it's always X value and Y value. But if we looked at some ordered pair on this graph, let's look at this one right here. Okay, so I put it in green. We can find that ordered pair simply by finding which values it corresponds with on the x-axis and then the y-axis. Okay, but this is a location on this graph, and all we're doing with an ordered pair is communicating what that ordered pair is as a location with numbers, okay? So right here, I would go down to the X number line here, And that is 1, 2, 3, 4, 5, 6, 7, 8. It's 9 to the right. So that's an x value that's 9. So in the ordered pair, I say, well, my x value is 9. For my y value, I just follow this line over to the y number line here, which is a y value that's starting at the origin, 0, 1, 2. That's a y value that's 3. Okay, so we get this ordered pair 9, 3. But again, there's an infinite number of ordered pairs you can put on the graph. You could choose this one or this one. Doesn't really matter where, as long as you know where it is as an ordered pair, because that is the location of that ordered pair of the point on the graph. So of course, our first example, state the coordinates of the point. We're expecting the coordinates to be as an ordered pair. Our x value is first, and then we will have our y value. Okay, so again, just to find our x value, I follow this line down until I get to the x number line. You could start at 5, you could start at the origin. I'll start at the origin. So that's 1, 2, 3, 4, 5, 6, 7, that's 8 right there. So it's an x value that is 8. But then I need its corresponding y value. So I just follow this over to the y number line. And I see that it's telling me what the y value is. It's just 5 right there, okay? So I get this ordered pair 8, 5. That's really all I need for this problem. On the assignment, I think it's got 2 different boxes that you got to fill in as 8, 5. If not, you may have to put the parentheses with the comma, but I believe it's just 2 different boxes there, all right? So this location, this point, this location on the graph is 8, 5. This may seem like an obsolete skill or maybe just too simple because you've done it before, but if you can't do this, if you cannot locate points on a graph, then the rest of this is going to be pretty rough. Because if I put on this thing that I put negative 8, 5, that represents a different location. It may look very similar to this location, and it would be similar, but it's not exactly the same location. So you do need to be careful with negatives and positives. Okay, well, can you put a point on a graph? Okay, well, hopefully we can. Up here, again, I see my x value is 12, and the y value is negative 75. That's kind of a big number for y value, negative 75. So we do want to be careful with this. You can see right here, this is called the scale of the graph. It tells us how much each line represents, both for x's and then for y's. So if I look at my x-axis right here, they've shown the x. This is going up by 3 each time, okay? So don't just count 12 lines and be like, oh, that's where it should go. And this one doesn't have 12, so don't say it's off the graph. No, it's not because of the scale, okay? So I'll start with the x is 12. I found it on the x-axis right there. X is 12. So that means that the location of this ordered pair, 12, negative 75, has to be on this, I'm going to call it a street or line. Okay, so on this street is this location. I just got to find out where negative 75 is for my y value, okay? Now on that's my y value, so I go to my y number line and I find negative 75, which I see that I've got negative 72 here, but I really want negative 75, which should just be almost like right below it. So I'm going to say that's negative 75. And then I just take this line and then I follow it over until I get to the x equals 12 line. And it should be this one. I can follow it down though, just in case I miss. Yeah, there it is. Okay, now it's not directly on a corner, right? What I'd call a street corner. That green point that I just put on the graph is the ordered pair 12, negative 75. Now, when you guys put this in the assignment, because it's going to have problems like this, you got to be pretty close. Okay, meaning if it has to be on one of the number lines here, make sure it is. Like if x is 12, make sure it's on the 12 number line. The negative 75 though, that's the one I kind of had to estimate on. It shouldn't be above negative 72, and it shouldn't be close to negative 80. Okay, so it needs to be pretty close to this. Again, it doesn't have to be exact, but it should be pretty close. Next up. We look at staircases like this, and we can talk about steepness, okay? So steepness of a staircase. Actually, steepness is just another word for what we call slope in math, which hopefully you remember, because slope we considered as rise over run. Now, rise is the y's because y's are up and down. Up or down, I should say. And then the run is the x's because that's either right or left. Okay, we'll get more into that here in the next slide. But Rise over run it's a ratio, okay? And we'll need to remember that it is a ratio. So this means for me that we're gonna be seeing this as a fraction quite a bit. All right, so up here it says, which of the three staircases is the steepest? So we're looking for the greatest slope on these. I'm gonna set up a fraction here, and then I want rise and then run. Okay, so my numerator is the rise, and I can see this rise it's showing is 5 inches. So that's my numerator, 5. The run here is 5 as well. So that's my denominator. I'm trying to color code those so we know the difference. But my slope here, in this case, 5 divided by 5, just comes out as 1. So this would have a slope or steepness of 1, which we can quantify as mathematically. At some point in time, some math nerd was like, let's find the steepness of this line and quantify it. So thank you, math nerds. On the next one, I'm going to set up a fraction again. My rise here is 3, so that's my numerator. And then my run here is 8. So that's left and right. There's 8. That's my denominator. If I were to put this into the calculator, 3 divided by 8, and we get 0.375. Okay, which is less. It's actually much less than 1. So this one right here is less steep than staircase 1. But what about staircase 3? Well, staircase 3 has a ratio of rise to run. I can see that it has a rise of 6 and then a run of 4. So that's 6 over 4, which would simplify into 1.5 as a decimal, okay? So I can see that 1.5 is the biggest of the three. So where it asks for which one is the steepest, it appears that staircase 3 is the steepest. Now, a common mistake with slope, especially when we look at stair steps like this, is students say, well, the number that's the biggest, that's the one that will have the most slope. So they'll say staircase 2 has the most slope, or be the steepest. No, it has nothing to do with how big the numbers are. It's a ratio of rise to run. Now, why are we looking at this as staircases? Because I'm going to be using stair steps to demonstrate the slope, okay? And the sooner you get used to it, the better off you're going to be in order to understand what slope is, okay? So yeah, the slope of a straight line is like a set of stairs, which is why we're going to see it quite often. But we need to understand rise over run, okay? Y's over x's, up and down over right or left. But direction is important. And that's what this is saying right here. Direction is important. For rise, which is either up or down, if you go up, then you're looking at the positive direction, right? Just like we saw in the number lines. If you go down, that's the negative direction. Well, the run is the same thing, but it's horizontal. So right would be positive, left is negative. You need to understand if you're going up or down or left or right, because that's going to make either your rise positive or negative or your run positive or negative. But keep in mind that if you see a slope with 2 negatives, it really should simplify into a positive slope, because 2 negatives make a positive. And do understand as well, if you see something like this, negative 4/5, this has only one negative sign. So if I need to assign that, which I will, I'll usually assign it to the numerator and make the numerator negative 4. And again, since that's my rise, that would be down 4 right there. So yeah, here's some pictures of stairs. This one you probably can't see because of the projection, but it's pretty steep. Looks like these people are just rock climbing through these stairs. The other vocabulary word we're going to need to be familiar with is the y-intercept. The y-intercept is the ordered pair where the line crosses through the y-axis. So if I had a number line, something like this, right here, I would have this ordered pair right there. It's almost at 0.5, but it's not quite there. That ordered pair, whatever it is, that would be my y-intercept. So the nice thing about the y-intercept, and I'm not going to write intercept because it's a long word, but the y-intercept is just a visual check, at least if you're given a graph like this. Of course, you could be given perhaps a different graph, maybe something like this one, okay? But again, this point right here, that's my y-intercept. Now, if I do this in a decent way, which I will try to do now, you could get a line that looks maybe like this one right here, okay? With lines at the end. Okay, now visually I can see this is going exactly through the ordered pair, 0, 1. And so I'm gonna need, sometimes I'm gonna need to identify that. For the assignment, we're going to need to see these, and they won't give us any fractional pairs like these ones were. If they give us a graph, they're going to tell us what the y-intercept is through the graph, okay? But we need to be able to notice that. Another thing you'll need to notice is that the x value for the y-intercept, since it goes through the y-axis, the x value is always 0, okay? So if I looked at the red ordered pair, I don't know what the y value is, but I know the x value would be 0. Same with the purple one, the x value would be 0. Then you'd have to find its corresponding y value, okay? That's because the x value on the y-axis is always 0. So here it says graph aligned with these features has a slope of -7/3 and a y-intercept of 0, -2. I am going to start with my y-intercept at 0, -2. So right at the origin, I would go down 2, which would give me this point at 0, -2. So I put that point on the graph. Now that I have it, I'm going to use the slope to find all of my other points on this graph. Okay, so it's showing -7/3. Like I said, I'd like to see this negative assigned usually to the numerator. So I'm going to make that -7 over +3. Okay, so the -7 tells me that it's going to go down 7 because that's my rise, which is up and down. And then my run there, 3 is positive, so I'm going to go to the right 3. And this is going to give me a stair step on the graph. Okay, so from the green ordered pair, the y-intercept 0, -2, I go down 1, 2, 3, 4, 5, 6, 7. Okay, so I just went down 7. Okay, and again, the down is the negative part of that. But then I'm going to go to the right 3 from where I ended there. So that's 1, 2, 3 to the right. And that is where my next ordered pair will be. Okay, so that's going to give me this ordered pair. Now that would be enough to graph. On the graph, you just need 2 points on the graph, then it makes the line. But since I'm doing it by hand, I'm going to put on another ordered pair, okay? So from the green point, though, I would go left 3 this time, and then up 7. So that's 1, 2, 3, 4, 5, 6, 7. And then I get this ordered pair. Okay, so these other two ordered pairs, looks like I got 4, -9. And then I also have this ordered pair at -3, 5. Now, I don't know the equation, but all 3 of these ordered pairs, if I were to replace into the equation, I'd get true statements, if you care. But there we go, some technology to graph this line, and that's it. Okay, so this blue line is the graph that has the features of slope -7/3 and then the y-intercept at 0, -2. Okay, slope equals 1/2 and our y-intercept at 0, 3. So let's get that y-intercept on the graph. Okay, so from the origin, I'm going to go up 3. 1, 2, 3. Boom, I found it. So this is the ordered pair 0, 3. Then my slope it's both positive. So I'm going to go, it's a rise of up 1. And then my run here is to the right 2 because it's a positive 2. Okay, so from here at 0, 3, I go up 1 to the right 2. And that gives me this point. And I know on the computer you'd have that done, but I'm going to go up 1 to the right 2. I'm going to continue this pattern, find all of the other ordered pairs. I'm not going to actually list them all because it's a lot. And again, hopefully this is more review. Up 1 to the right 2. And then up 1 to the right 2. And then up 1 to the right 2. Now, as fun as that was, I'm also going to do the stair steps backwards too, okay? So that'd be left 2, down 1. I'll put my points in later though. So left 2, down 1. Left 2, down 1. Left 2, down 1. Left 2, down 1. There we go. That gives me all these ordered pairs. Okay, now that I got those on the graph, I'm now ready to graph the line. So I'm just going to connect all the points. And this blue line is the line that represents a slope of 1/2 with the y-intercept of 0, 3. But hopefully you see at least the importance of the stair steps because you can do them to the right, you can do them to the left. It's a replication of all the stair steps. And yeah, hopefully that's good. The 2 things that you need in order to graph the equation of a line are the slope and the y-intercept. Really any point would do though. course, you could have 2 points and that'd be fine. But on those last two examples, they gave us the slope and the y-intercept just directly. They said this is the slope and this is the y-intercept. In the future, they're going to give that information to us in an equation format, okay? So you can see the slope here is m, and then the y-intercept is what we call the b value. All right, now the y-intercept, this is just going to show one of the values. Don't forget that it actually is an ordered pair at 0, and then whatever this b value is. Keep in mind also, if it's a minus sign right there, it's going to make that y-intercept a negative. And so if you see minus something like -2, it'd be a -2 y-intercept at 0, -2, okay? But the slope is always the coefficient of x. If it doesn't show the slope, it just shows an x, we'll have to remember that's a phantom 1. Okay, so a few examples for us, all right? Right here, I would probably start with this because it is my y-intercept. I need some point on the graph just to start with, okay? And that is showing, it's not 0, 3. Don't forget the minus sign makes this a -3, okay? So my y-intercept, let's put this on the graph, 0, -3. I got it, okay? And then I see my coefficient of x is going to be my slope. Now it's a -1/4. I'm going to keep the negative in the numerator, so it's -1/4. That tells me that it's going to go down 1 and then to the right 4 from that ordered pair that we put on the graph. So I go down 1 to the right 4, down 1 to the right 4, and that's the points I can put on to the right. But I'm going to copy these stair steps to the left. Left 4 up 1, left 4 up 1, all right? And then I have all the points I can put on the graph. I'm ready to put the line on. I did it. Okay, so again, they've given us the same information just in a different format. We have the slope and y-intercept. Those are only two things we need in order to graph any straight line. Now on this one, some students get confused because they're like, hey, Mr. Sal, there's no y-intercept on this one. There is a value here that you can't see. And remember, it should come in the form of y equals mx plus b, right? So y equals mx plus b. It's just not showing the plus b. So, but since it is plus, we've seen this before when solving equations. It has to be a phantom plus 0. So if it's a plus and it's not being shown, it has to be plus 0, okay? Now the reason why this is important, because that is our y-intercept, which is directly at the origin, 0, 0. That's the origin, okay? So a little bit of review there on vocabulary. But I know that 0, 0 is just right in the middle of the two axes, all right? So that's 0, 0. And then from there, I have my slope, which is the coefficient of x, always the coefficient of x, which is 2/3. Both these are positive, so it's going to go up 2 and then to the right 3. Okay, so from that point, up 2 to the right 3, there's that one, up 2 to the right 3, there's that one, up 2 to the right 3. And again, I'm going to copy these stair steps backwards, so left 3 down 2, left 3 down 2, left 3 down 2. Okay, and that's all the points I can fit on this graph. So now I'm ready to draw the line. Not too bad. Okay, so that blue line represents the equation y equals 2/3 x plus, and we don't really need the plus 0. But I'm going to remind you that like this point right here, that's at 6, 4. If you replace the x with 6 and the y with 4, you get a true statement. Or you could use this point right here. Okay, that's at -9, -6. If you replace the x with -9 and the y with -6, you get a true statement. This is going to be true for any point that's on this line, even the fractional ones in between these ordered pairs that we know. Any point on this line will make this equation a true statement, which is important to remember. For this one, we can't see the y-intercept here, right? So I know my y-intercept is going to be at the ordered pair 0, 1. Of course, the x value is always 0. I can put this on the graph. That's my ordered pair 0, 1. But then it's like, well, what is the what's the slope right there? It's a phantom 1. Now, why is it a 1 this time instead of a phantom 0? It's because it's being multiplied. And if numbers that don't have to be shown when they're multiplied is just a phantom 1, okay? So that 1, that's my slope. I got a slope of 1. But that's not a fraction, so I can see my rise and run, right? So I'm going to have to make it 1/1. So that's going to be a positive 1/, positive 1, that's up 1 to the right 1. From that purple ordered pair, so I can fit a lot on this graph, by the way. So there's up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and then I just continue the stair steps as far as I can go. There it is. Actually, I can go backwards too, so I can go left 1, down 1. And I can just continue this left 1, down 1 business until I get to the end of the graph as well. It's not really hard work. It's just a lot of work, I guess. At least hopefully it's not hard. So that's as much as I can fit. And now I'm ready to put these points on the graph. Here I'm looking at the blue line there. So that blue line represents the equation y equals x plus 1 or 1x plus 1, either way. But again, all of those ordered pairs that I put on there, what is that, 21 of them? 20 of them? All 20 of those would make the original equation a true statement. So this one's saying write the equation of the line that's graphed below. Okay, that's nice. We know we're going to put this in what we called slope-intercept form. So again, m is our slope. Y equals mx plus b, and the b there is our y-intercept. For me, I think the y-intercept is the easiest just because it's a visual check. So I'm going to set this up again, but I can see pretty quick my y-intercept right there is at 0, 5. Sorry, 0, negative 5. Okay, so since it's a negative 5, I'm going to have to show this as minus 5. All I need now is the slope, okay? Now I'm going to put my fraction line in where the slope goes. Okay, but I can see, I got 1 point. I just need any other point on this graph. I'll choose this one right here. Okay, and that's at, looks like 6, negative 5. Okay, so what's my rise on this one? Well, it looks like it's going up 0. So that's my numerator. And then for me, the two that I chose, this goes to the right 6. Okay, so 0 over 6. I can simplify this and just write y equals 0x minus 5. Okay, and that's a pretty good equation. It does declare what the slope is. But what we're going to see on the assignment is that it wants it even more simplified. Any 0 terms like this need to just be made phantom terms. And so I make that a phantom term, I just ignore it, and I end up with y equals negative 5. This is what they're going to want. This also tells us something about slope of 0. Any flat lines are going to have a slope of 0. But you see that you're going to see as well that it takes on this pattern y equals whatever the number is, and this number is always going to be where it goes through the y-axis. How do you know it's always going to be y equals? Because it's on the y number line. More to that later. So any lines with 0 slope, they just have no slope. And mathematically, we quantify this as the lowest amount of slope that a line can have. It's 0 slope. Okay, so if it has no slope, again, you could write it as y equals 0x plus the y-intercept, but we're going to simplify that into y equals the number, which is the y-intercept. You just need to find where these flat lines go through the y-axis. That's it. So this one ends up being a little tricky sometimes. Right? I'm expecting this to be y equals some number. And what number is this? Well, what value is this red line going through the y-axis? That's 0 right there. Okay, so this is just y equals 0. Boom, you're done. Okay, again, we know the slope is 0 because it's a flat line. I don't really care about that anymore. I just want to write y equals 0. Okay, what if you get lines without a y-intercept? And what does this really mean? Well, this means that if it has no y-intercept, the line is vertical. Okay, so again, that's just straight up and down. Okay, so in the past where we've seen perhaps a line like this one, you'd say, well, it'd be like going on a sled, right? You can get on a sled and then you can go down the hill and it's great and you can have fun. Right? Or if you had a line like this one, maybe it's kind of steep, but you'd have to pull your sled back up the hill in order to go down it, right? But now we're looking at lines that are straight up and down like this one. We'll pretend like I'm a good drawer. And if you wanted to go down this hill, it probably isn't going to end well, okay, on your sled. So these ones have infinite slope. It's the most amount of slope mathematically that we can quantify, and that's infinity. Usually if it's an infinite slope, though, we say that it's an undefined slope. But these equations, since they don't have a y-intercept, we say it's x equals now. So you have to keep track of these vertical lines like this are now an x equals equation, not slope-intercept form, because again, we can't even quantify that slope. So for this one, we say right here, it's a vertical line. Since it's a vertical line, I'm expecting the equation to be x equals something. What is that something? Well, I just got to check my x number line. Where does this line go through the x number line? It's at 2. So my equation is x equals 2. That's it. So on the assignment, you're going to see stuff that looks like this. What type of line is this going to be? It says graph the line x equals 7. What kind of line? Is it horizontal or vertical? Well, it's x equals, so I'm expecting a vertical line, so you would box that in. So since we've chosen that it's vertical, which it is, it's just, all it does is pop up this line right here, and you can see this little yellow dot right here. You just got to click and drag it to where it should be, and that's where x is 7, right? So you're just going to drag this over to 7, and then you end up with something like this. Okay, so yeah, by this time, this graph would have been gone away, and then you would have seen this one, all right? Now, since you do have this as x equals 7 right here, you just leave it like that. You click submit, and it gives you full credit. Of course, if it was a y equals a number equation, then it would have been a horizontal line, but this is the one that we have. So graphing lines with 2 points, you just graph the 2 points, draw the line between the 2 points. That's really all you got to do on this, okay? And again, the technology will do it for you as long as you just click on the 2 points, then you choose the line option, then create the line. In addition to this, though, the assignment's going to say, well, then you got to write the equation for it, which we've seen. The 2 things you need to write to the equation is the slope and y-intercept. Now, the slope can be found 2 ways. Of course, you can find the slope from 2 points with the stair steps. And you'll notice between the y's here and the x's is subtraction. That's because subtraction is distance between the 2 points. And if you get negatives or positives here, that will tell you up and downness or leftness or rightness. But what they're going to do is they're going to give you some ordered pairs, okay? Well, 2, actually. And then you'd have the first ordered pair. That'd be your x1, y1. And then your second one can be your x2, y2. But it doesn't matter which 2 you choose because slope or steepness is the same because these are straight lines. It's the same no matter which 2 you pair up or if you put y2s and x2s here and x1s, y1s. It's important to remember that the ordered pairs are directly above and below each other, but it's x, y, x, y. Denominator for x's, numerator for y's. That's because the numerator is the rise. And the denominator is the run. But again, the 2 things you need to write an equation is the slope and then the y-intercept. Slope, you can use the slope formula, or you can use stair steps to find your slope. And I think we'll do it both ways on this. Okay, but let's get these points on the graph first. So I'm going to start with 4, -1. So my x is 4, my y is -1. From the origin, I go to the right 4 on the x-axis, and then down 1 for my y number. That's going to be 4, -1. Okay, so I found 4, -1. Now I will go to 8, 2. So from the origin, I go right 8 up 2. And that would be the ordered pair, 8, 2. Now that I have that, I'm ready to draw the line between those 2 points. And that will at least get the graphing portion done. There we go. And if I'd drawn that better, it would go through all the corners, but it's still good. But this is what we got. That would be the graph. That's that part of it. But then it says up here, it says then write the equation of the line. Okay, so I'm expecting this to be in the slope-intercept form. Y equals mx plus b. And as before, the y-intercept is just a visual check. I can see it goes right through here. Even though I drew that poorly, it still is right there. That's going to be at 0, -4. So since I see my y-intercept at 0, -4, my b then, my y-intercept, -4. What I need now is the slope, and there's 2 ways to find the slope, okay? You can find the slope simply by making a stair step between the 2 points that were given. And I see for me, this goes up 1, 2, 3, and then it goes to the right, 1, 2, 3, 4. So I can make my slope already. That tells me my slope is up 3 to the right 4. It should be 3/4, right? Or if you want, you can use the formula, which we saw before. So you can also use the formula. Slope is like this. Okay, so remember, it's always subtraction signs. They gave us the two ordered pairs. I'm going to start with the green one, and that was at 4, -1. And then the orange one, my x is 8, my y is 2, so that's an 8, 2 ordered pair. Now, when I put this into the calculator, I'm going to need parentheses around the numerator and then the denominator. The fraction line is just the divide button, okay? So in my calculator, again, just using the calculator, I type in -1 minus 2 in parentheses. Then I push the divide button. That's going to give us the fraction line. And then I also type in parentheses 4 minus 8 and close the parentheses. When I put this in the calculator, it tells me, hey, your slope is 0.75. Well, I don't want the decimal. I want the fraction. So then I go to my calculator and I type in math. It's 3 buttons below from the top left, and then push enter, enter. And that will tell you the slope is 3/4, just as we had found it before. So my slope, even though we found it twice, it's still the same, 3/4. And this is the equation that we want. Y equals 3/4 x minus 4. Notice the x is not part of the fraction. It's being multiplied, but it's just not part of the fraction. Okay, so that's two different ways. I'm going to be using the formula, but again, if the stair-step thing makes more sense to you, then do use that. Here we got the ordered pairs, -7, 1. So I'm going to start there. Let's get this on there. -7 and then +1. So from the origin, left 7, up 1. So that's my ordered pair, -7, 1. And then also this ordered pair, x is -7, y is -9. So left 7 from the origin, left 7, down 9, puts me right here. Okay, now that I've got that, let's go see, let's see if we can get this on the graph. It's not great, but I'm willing to stick with it. I end up with a vertical line. I know I didn't graph that very well, but it's a vertical line, it's straight vertical. So when it says over here, hey, write the equation for the line, it's going to be an x equals situation. And again, what is x going to equal? Well, I can see it's going directly through this ordered pair at -7, 0. So that's going to be my x value, -7. X equals -7. That's the equation. Now, if this had any slope at all, I would have found it. Well, I mean, it does. It's just infinite slope, right? So just to take us through that process, if you wanted it, you'd say, well, what's our slope? Well, slope is always going to be subtraction. And I got my green ordered pair at -7, 1. And then my orange ordered pair at -7, -9. If you put this into the calculator, it's going to tell you something like a divide by 0 error, which is just another way for the calculator to say, this number is too big. It's infinity. I can't even show you what it is, so it just gives you an error. That also is another clue that you have an x equals equation, not y equals mx plus b situation. That's it. There's our 4 objectives. If you can do this stuff, then the homework will go very quickly. You should be able to finish before the end of class. So when you go home, you can spend time with your families and not do stinging math. If you don't finish by the end of class, you'll have time next time. If you're not going to do jack squat, then you'll probably never finish. But 4 objectives. I can plot points on a graph, which we did. I can determine coordinates of points on a graph, which we did. We graphed and wrote equations from graphs in slope-intercept form, and then graphed and wrote equations of vertical and horizontal lines. So hopefully, again, you feel pretty good about that stuff.